Hey guys, today we are looking at factoring quadratic equations. For the most part, factoring should be a review to you from Algebra 1, but since it's been a couple years, we're going to start off and go through and review some of those things. So the first thing you always want to look for is whether you can factor out a greatest common factor or a GCF. So we want to look at example 1 and see what do these three terms all have in common. So if I look at just the numbers, the coefficients in front of the variables, a 3, a 9, and a 15, I can take out a 3. All of them will divide by 3, so 3 is the largest factor I can take out. If I look at the x's, I have 2 x's in the first, I have 3 x's in the second, and I have 5 x's in the third. So the largest thing I can take out is 2 x's, which we write as x times x, or x squared. I have 1 y in the first, 3 y's in the second, and 2 y's in the last one. So the largest thing I can take out is 1 y. So then it's like you're dividing that out. You have factored that out, so we divide 3x squared y by 3x squared y. It's all gone. We have 1 left, because anything divided by itself gives us a value of 1. So then 9 divided by 3 is 3. X cubed divided by x squared. Remember that when you're dividing with exponents, you subtract. We have 1x left. Y cubed divided by y is y squared. And then 15 divided by 3 is 5. X to the 5th divided by x squared is x to the 3rd. And y squared divided by y to the first is just y. The next thing we look for is whether or not there are any special patterns that exist. So one special pattern that we know of is the difference of 2 squares, and that's when you see 2 squares being subtracted. That's what difference tells us. So a squared minus b squared will always factor into a plus b and a minus b. So in this case, 16y squared is 4y squared minus 225. Take the square root of that, and we get 15 squared. So when we write this, we would write 4y plus 15 and 4y minus 15. All right, then for part B, same thing. 64x squared, the square root of that is 8x. And then we have plus 3, that's the square root of 9. And then we have 8x minus 3. And the last one, we have y squared plus 25. Well, as we just discussed, this is a difference of 2 squares. This plus sign tells me that that's not factorable using our difference of 2 squares. So we would leave that as is. All right, then step 3, we would look at factoring by grouping. So if the expression contains 4 terms, we group the first 2 terms and the last 2 terms, and we factor each set. Then we factor the common term out of both groups. So I'm going to look at the first 2 terms here and the last 2 terms. And I notice x cubed and 2x squared, they have an x squared in common. And left over I have x minus 2. And then 4x minus 8, they have a 4 in common and a positive 4, so I put a plus sign. And I end up with x minus 2. So now I'm looking, what do these have in common? And it should be the same, it should be what is inside parentheses if you factored correctly. So they both have an x minus 2 in common. And then what do we have left over? Well, we have x squared left over, and we have a plus 4 left over. So that's the factored form. And you could write that as x squared plus 4 and then x minus 2 second if you wanted. All right, let's try another one of those. So we're looking at the first two terms. So 5x cubed plus 3x squared, I have an x squared. And then I have 5x plus 3 left over. 10x minus 6, they both have a minus, so I'm going to go ahead and take out that negative. It looks like they're both divisible by 2, so I'm going to take out a 2. And I end up with 5x plus 3. So I have 5x plus 3 that will come out of both of those terms. And then left over I have x squared minus 2. We could factor that second one down more since it's not a perfect square. We're not going to do that for now. All right, step 4. You may want to pause the video if you are copying all of this down and you hadn't printed out notes ahead of time. Given a quadratic, put the trinomial in standard form. So this means the highest exponent to the lowest exponent. So ax squared plus bx plus c. We're first going to see if it factors by using the discriminant b squared minus 4ac. If b squared minus 4ac is a perfect square, it's factorable. Then we're going to go ahead and factor. So multiply a and c, so the first coefficient and the last. Then find the factors of a times c that add up to b, the middle coefficient. Split the bx term into those two terms with the coefficients found in step 3. Finish factoring by grouping. Okay, so let's first determine, let's use b squared minus 4ac to see, does this factor, b squared minus 4ac. So b squared is 17 squared minus 4 times 5 times 14. So when we do 17 squared, we get 289. Minus 4 times 5 times 14, we get 280. 289 minus 280 is 9. So that's a perfect square, which means this is factorable. Okay, so then it tells us to, first, are we in the correct order? Yes, we have x squared, then x, and then no x terms. We're going to multiply a times c. So 5 times 14. That gives us a value of 70. We need to find two numbers that will multiply to 70 and add up to our middle term of 17. You may have seen this like this. So those two numbers would be 10 and 7. 10 times 7 is 70. 10 plus 7 is 17. So then I'm going to split out the middle. I'm not changing the problem, but I'm writing 5x squared plus 10x plus 7x plus 14. So I've just taken that 17 and I split it into 10 and 7. So 5x squared plus 10x. Now I'm looking at the first two terms to factor by grouping. I can take out a 5x and I'm left with x plus 2. 7x plus 14, I can take out a 7 and I'm left with x plus 2. So now I have 5x plus 7 and I have x plus 2. Let's try another. So first we want to determine, is this factorable? So b squared minus 4ac. So I get negative 12 squared minus 4 times 9. So 144 minus, and then 4 times 4 times 9 happens to also be 144. So 144 minus 144 is 0. So that's an interesting thing to note, but our discriminant here is 0. So yeah, we can factor this. Let's see, I can't pull anything out. There's no greatest common factor. So I'm going to start by looking for two numbers that multiply to 36, 4 times 9, and that add up to a negative 12. So I need two numbers that multiply to 36 and add to negative 12. Well, I need it to multiply to a positive, but I need it to add to a negative. So negative times negative will give me a positive. Negative 6 times negative 6 would give me a positive 36, but would add to negative 12. So I have 4z squared minus 6z minus 6z plus 9. So now in the first set, I can take out a 2z. I'm left with z minus 3. No, 2z minus 3. Sorry. And then in the second set, I can take out a minus 3. And then I'm left with 2z minus 3. So notice I have 2z minus 3 and 2z minus 3 left over. Or we have 2z minus 3 to the second power. We'll discuss that relationship between the discriminant and why that happens with the double factor there in class. Let's look at part C, and if you're feeling confident, I would go ahead and pause this video and try to do this one on your own. The first thing I am going to do here is take out a greatest common factor term. I notice that all of this will divide by 2. So I have 2 out front. I'm not going to make it disappear. It's just going to stay out front. So 7x squared plus x minus 6 makes that problem a whole lot nicer. Now, I want to double check. B squared minus 4ac, so 1 squared minus 4 times 7 times negative 6, and I get 1 plus 168. So 169, that is a perfect square root. So, let's see what we can factor out of here. So I need two numbers that multiply to negative 42 and add up to a positive 1. Well, immediately 7 and negative 6 come to mind. So I have 2 out front, and then I have 7x squared plus 7x minus 6x minus 6. Still bring that 2 out front. Of those first two factors, I can pull out a 7x. So I'm going to use brackets here to help me. So I pull out a 7x, and then I end up with x plus 1 left over. And then right here in the second one, I pull out a minus 6, and I'm left with x plus 1. So then I have still 2 out front. I have 7x minus 6, and I have x plus 1. All right, let's look at a couple more of these. So I have 12x squared plus 3x plus 3. First thing I'm going to do is pull out GCF. So everything divides by 3. So I end up with 4x squared plus x plus 1. I'm going to do a quick b squared minus 4ac. So 3 squared minus 4 times 4 times 1. So 9 minus 16 is -7. Ooh, that doesn't look promising. So we're going to stop there, and that's your answer. We were able to only pull out a greatest common factor. All right, 4u squared minus 36. Hopefully this one looks familiar to you. We see our special pattern. So I'm looking, though, and I see that 4 and 36 both divide by 4. So I'm going to take out the 4, and then I have u squared minus 9. So the 4 is out front, and then I have u plus 3 and u minus 3. And that's all we can do there. So we are finished with that one. All right, guys, that is it for this lesson. If you have questions, please come in and see me. I will see you in class.